Okay, hi everybody. This is going to be our walkthrough of how to find masses and percent abundances of various isotopes using their average atomic mass and the average atomic mass formula. So a new atom was discovered called dolium. Dolium has 3 naturally occurring isotopes. Its average atomic mass is 150 grams. Using the average atomic mass formula, fill in the chart. So this chart has some information that is given to us, and we have to fill in the blanks using our formula. So first we have dolium-149, and its percent abundance is 82%, and its mass is 149.45 grams. We have to find its weighted mass. Next we have dolium with an unknown mass. Its percent abundance is 15%, and we do not know its mass or its weighted mass. Lastly, we have dolium-154. We do not know its percent abundance, but we do know its mass is 154.32 grams. We also need to solve to find its weighted mass. So the first thing we're going to do is we're going to plug what we know into our average atomic mass formula. So dolium-149, its mass is 149.45 grams. And its percent is 82%. Please always remember when you are using percentages in an equation, you want to convert it to its decimal form. 82% is really 82 over 100, which is 0.82. If you forget to do this step, you're going to have some very, very large numbers. So it's going to be 149.45 multiplied by 0.82. When we multiply 149.45 by 0.82, we are going to find dolium-149's weighted mass. This is the mass that is contributed to finding the average. So we're just going to find that right now so we can fill in an entire row. So it's going to be 149.45 times 0.82. We get 122.549. I am going to make this 122.55. On the periodic table that we use and in the equation, we see that the average atomic mass is 150 grams, so we're just going to keep it to 2 decimal points to make our lives easier. So our weighted mass would be 122.55 grams. Don't forget your units, they're very important. All right, next I'm going to put in what we know for dolium unknown mass, okay? Our mass is unknown. I'm going to show that with a variable. And then we know that when we do figure out the variable, it's going to be multiplied by 0.15. Because again, 15% is really 15 over 100, or 0.15. We're going to come back to our middle isotope of dolium because we need more information to finish that. Sorry, I didn't write down here, 122.55. All right, moving on to our third. Dolium-154 has a mass of 154.32 grams. This was given to you on the table. But the percent was not given to you. You can figure out the percent when you realize you're given the other 2 percentages. So you have 82 and 15%. So to figure out that last percent, you can subtract the percents that you know from 100 because you have to have 100% to show the whole scope of your isotopes. So if you want, if you're really good at math, you can do this in your head. But I'm just going to do 100 minus 82 and then minus 15. Our last percent is 3. So this is a very rare isotope of dolium. So our last isotope of dolium is 3% naturally occurring, also known as 3 over 100, which is 0.03. That's a very small number. So you're going to do 154.32 multiplied by 0.03. I'm going to plug that into my calculator so we can figure out the weighted mass. So it is, just trying to make sure you can see both. So 154.32 multiplied by 0.03. That's going to give us 4.6296. Since we're going to keep this to the second decimal, we're going to round this to 4.63. So 4.63 grams. And then we're going to put it in our weighted mass of 4.63 grams. All right. So for our average atomic mass formula, we know that when we add up the mass multiplied by the percent or the weighted mass of all three isotopes, we get our average atomic mass. Our average atomic mass was given to us in the equation as 150 grams. So our formula currently looks like this: 122.55 plus this middle that we still haven't solved yet, x times 0.15 plus 4.63 gives us our average atomic mass of 150 grams. So what we're missing currently on our table is the weighted mass of dolium with the unknown mass, and we're also still missing the mass of dolium as itself, okay? So to get this, we can easily get the weighted mass from the average atomic mass if we take out the two masses that we already know. We know 122.55 goes with dolium 149. We know 4.63 grams of this average comes from dolium 154. So you're going to do 150 minus 122.55 and then minus 4.63. And the number that we get is going to be our weighted mass of our unknown dolium. So we're just going to do that in the calculator. And I'm going to do it under here so you guys can follow along. Okay, so 150 minus 122.55 minus 4.63. This is going to give us a weighted mass of our unknown isotope of 22.82 grams. Okay. So we can fill that in our weighted mass. All right. So just to show what we did, I'm going to take this out and take this out. So the only part left to our table is x times 0.15 equals 22.82 grams. To solve for our mass, to solve for our variable, all we have to do is get our variable by ourselves. So we're going to divide by 0.15 on both sides. So then, lastly, 22.82 0.82 divided by 0.15 is going to give us 152.133333. So we can leave that as 152.13. If we were to give this a hyphen notation, it is closer to 152 than it is to 153. So just write 152. And you have solved your table. So please keep in mind when you're doing these out, remember that you always want you to convert your percentages into decimal spots. And then after that, it's just plugging in what you have to your equation and solving from there. All right? This one should make sense too. If we look at our average atomic mass, it's 150 grams. So we know that our most naturally occurring or our most abundant isotope is going to be closest to 150. If we look at our isotopes, 149, 152, and 154, Dalium 149 is 82% abundant. That is the closest number, or 149 is our closest number to 150. All right, so I hope this helped. If you have any questions, feel free to email me as well. All right, thank you.